You recognize this? You know what that means? All right. You guys are going to be a tough group. I'm glad to be here. This is for my first time in Nepal. And I'm just so glad to get to have a chance to meet all of you. I'm Mike. Just call me Mike. I teach biology. I teach primarily students that want to become nurses. I have had some students that have become medical doctors, but mostly nurses. So, no matter what type of science that you're in, we have a certain process, a scientific process. Do you know what that is? Yes, no? It's okay to be wrong in my class. I'm wrong a lot. The scientific process. First of all, we have to have observation. And you can read English, right? Observation. Just seeing with your eye. And sometimes you sit there and say, why does that happen? That's the beginning of scientific process. I want to start steel ball and a piece of cardboard, right? One's a lot heavier than the other, isn't it? One's much heavier than the other, right?
Heavier. Which one is heavier?
That's much heavier. Okay. Which one's going to fall faster? The steel ball is going to fall faster? I want to vote. How many say the steel ball is going to fall faster? Okay, there's a lot of you. How many will say that the piece of cardboard is going to fall faster? How many say they're going to fall the same? Okay, so let's check this out. All right. Which one fell faster? Steel did, didn't it? So we're right. Why does the steel ball fall faster? Too many. Go ahead. Right? Yes. Because it's heavier. Okay. You agree with that? The steel ball fell faster because it's heavier? You say no? You say no?
Yes, sir.
Why?
Because external radiation don't act.
I'm sorry, I have a hard time hearing.
Because external radiation don't act.
All right. I'm not going to be able to fool you. So anyways, you may sit. We have observed that the steel ball has fallen faster than the cardboard. And so we can make a prediction. And most of you said that the ball fell faster because it's heavier. And some of you didn't, but most of you did. And so we're going to make a prediction. This is the second step of the scientific process. Now, I have another object that weighs exactly the same amount as this piece of cardboard, this little cork ball. Okay. About the same, aren't they? Okay. So our prediction is that the steel ball is going to fall faster than the cork ball, right? Except for a couple of you in the back. Okay? That's a prediction. And so now we have to do what is called the experiment. And so this simple experiment, way over there. Which one hit my briefcase first? You guys are going to have to help out here because you're the only ones that can see. Which one hit first? The wood did? Let's try it again. The wood again?
No, it's a both. It's a both.
They said both? You said both? Okay. Is that what we had originally said? Because this one was heavier and this one was light? We thought this one would fall faster, right? But now we've done an experiment and we make a conclusion. The conclusion that both of them fell at the same time, right? Our prediction was that the solid one would fall faster than the light one, and so our prediction was wrong. That's science. And so, since the prediction was not, or the conclusion did not agree with the prediction, we have to change what the prediction is. Whenever you have science, that's what you have to do. Never have a preset idea of what's going to happen when you do science. You always have to run experiments. If you can do that, you'll make great scientists. Because that's what science is about. How many of you are planning on going to college? If you're going to go to college, planning on it? University?
Campus.
Campus?
Yeah.
Going to campus? Yes? When you take your science, that's what you're going to have to do. That's all I had to share with you, just to make sure that you understand what scientific method is.
Thank you.
Go ahead.
Thank you.
This is what all of the great scientists have done. Newton, Galileo, my favorite, Louis Pasteur. Okay. They all do these experiments. And you have to do experiments without having a closed mind. You have to accept what is new. Anything else I need to say?
No, the same thing which you wrote below, I was thinking to write above, so they can understand in the scientific method what is needed here. That's all.
The scientific method is this. When the conclusion matches the prediction, many, many times over, then we have a theory. Questions? You don't have to be polite. I'm not used to that. No questions? Does anyone know the math of why these two fall at the same time? Do you know what math for why these fall at the same time? Do you know the math and physics of why these two fall at the same time? Since they're so good, I have to pull this up. Okay. We know that, right? The force is the mass times the acceleration. And the force of gravity is the mass times this gravity, right? That's true as long as we're close to the Earth's surface, right? In free fall, this is actually F net, and this is F gravity. Just through in a vacuum, and we can substitute, right? Am I making sense? And of course we can cancel out the mass in both cases. And so acceleration. Okay. And so notice that does not matter what an object weighs, they all fall at the same speed. So the question then is, last question for you. And I haven't picked on anyone over here. Why does the cardboard fall slower than the steel ball? This is the rearrangement of the prediction. Why does the steel ball fall faster than the cardboard? Anyone? You had it before, go.
Because it has air resistance.
All right. The difference between the two is air resistance. So that if we let these two fall in a vacuum, they would fall at the same speed. I have to tell you that you guys have done better than many of the 11th graders that we have in the United States. They would not have understood what I was talking about at all. Not only that, but you have to listen to me in another language, and you still do better. So give yourself an applause because you've done fantastic. Thank you for having me talk to you.